Stan Gibilisco here with a little bit of a tutorial on what exactly is meant by the term rectangular response. Rectangular response in a radio communications receiver. So I've set up two different displays here. This one over here on the right is a program called HamScope. It is intended for digital modes in ham radio reception and transmission. And the one over here is called Digipan. That one also is intended for the reception of digital signals in ham radio, but they are two different types of programs. They work on slightly different principles. HamScope seems to be a little bit more versatile, but Digipan, contrary-wise, over here is a little easier to use. You can download both of these, just Google on them. HamScope, HamScope, and Digipan, Digipan. P as in Papa. So if you want these programs, they're very, very low footprint programs, and you can get them by just Googling on them. Well, I have the radio tuned so that there's some white noise, more or less, coming through, although it doesn't sound much like white noise because it's passing through a filter with a rectangular bandpass response. But now by rectangular we mean that the skirts, that's these edges right here and right here, right here and right here, and also on this program right here and right here, are very steep and sharp, so that the range of frequencies that it will let through, in this case roughly 400 hertz to 900 hertz. In the audio spectrum, that's 500 hertz wide, centered right about at 650 hertz. That is a nice frequency for the reception of Morse code, and in fact that's what this filter is intended to do, is to receive Morse code. What you see here, the lesser levels are black, then blue, and then it turns to violet. And if there was actually a signal coming in, which I can actually arrange for, you can see what that signal looks like. This is a frequency domain display, meaning that the frequency is the independent variable or the domain of the function on the horizontal axis in both cases. You can see them up here. I don't know if you can read these numbers on your screen. 1,000 hertz, 2,000, 3,000. Here's 1,000 and 2,000. And you can see the rectangular response quite clearly if you just let noise come in without any signal. We can narrow that filter down. Now it's all the way down to a band pass of, what does it say here? I'm trying to read that off of here. 250 hertz wide. Again, a rectangular response. Now that means that the band pass, the response within that band pass is more or less flat. And the response outside is more or less flat. And the skirts are steep, so it kind of looks like a rectangle. It looks a little more to me like the Devil's Tower in Wyoming. Have you ever seen that? That's what that looks like. You may wonder why there's an orange curve and a green curve here in HamScope. The orange curve is a slower response, so it produces more of an average over time, whereas the green is a more rapid response and produces more instantaneous results. Now this frequency again is on the horizontal axis. Amplitude is indicated by color, And then time. It also shows the third dimension of time. I think that's extremely clever. They call that a waterfall display. You can make this particular program here, Hamscope. That'll also show you a waterfall. But the spectral display, this just gives you two different renditions here of what you can look at. You can look at it in two different ways. Now let's narrow this response down to only 100 hertz wide. Again, rectangular. Now that really looks like the Devil's Tower right there, that orange thing there. A couple of little buttes over here to the right. These are audio harmonics coming in the artifacts of the receiver. They're not actually part of the bandpass filter. I believe that they are occurring in the audio part of the receiver. You can see them maybe is a very faint blue here and here, but the main response is right there. Now we can also widen this out, way out. Now it's 1500 hertz wide. That's what I have this set at, roughly about 700 hertz here to about 2300 hertz. That looks more like about 1600 hertz wide to me, although I believe I programmed the radio for 1500. You can see once again it looks like a rectangular response here. Now this is a very low flat butte. Then we can narrow that down to only 50 hertz wide. And I use this for the phase shift keying mode to zoom right in on signals like that. Like that. 50 hertz wide. It's supposedly a rectangular response, and maybe we can get a little better view of it by zooming in on it in Hamscope. Well, they're doing the best they can, but when you get down that narrow, the response isn't quite so much rectangular. Now, back in the olden days, even the wider responses, like 500, 1500 hertz wide, they had this bell shape. The skirts are not steep. See that? They're shallow. You can see that very clearly in the spectrum. Not so easily can you see that in the waterfall type display, but you can see it very clearly in the spectrum. That's the way that filters used to be before, in the days of more sophisticated digital filters that provide this rectangular response. The advantage of having a rectangular response, now there I've widened it way out, 2700 hertz wide, 1500 hertz again. Then we can go to the CW mode, 500 hertz wide again. See that? We can zoom in a little bit on that. See how steep those skirts are? The neat thing about that, see, is that if you want to tune a signal, you don't want to hear it right there. You're not going to hear it very well, but you are here. It's more like a square window that you can look through, instead of, like, imagine trying to look through a lens. You'd only see what's exactly in the center very well. Maybe that's not such a good analogy, but the idea here, the whole idea behind this rectangular response, is to make it easier to receive signals. So let's go back up. This is a ham radio station. You see that orange line right there? That's the signal. And here the signal shows up as a sort of a pip. There's a little better, stronger signal, less noise. Now let's tune gradually away. Gradually away. You can still hear it real well. You can still hear it. But then it falls off that cliff and disappears. We can go back up to the top, the higher frequency end. Listen. Fell off the cliff. Fell off the cliff. It's just above the frequency. It's maybe right up here. Maybe right up here. Then I tune it back in. Tune it back in. Get it right about in the center there. Then if an interfering signal comes in real close in frequency, narrow it down to 250 maybe. If that's not enough, narrow it down to only 100. Now that's what is meant by, that's a good bandpass filter on this ICOM IC746 Pro ham radio transceiver. Stan Gibilisco signing off. My ham radio call sign is W1GV Whiskey 1 Golf Victor. Want to learn more about all this kind of stuff? Get my book, Teach Yourself Electricity and Electronics. So long.